Hello everyone. So today in this runtime terrain generation system, we are going to work on how to prioritize the generation of landscape tiles around the player first. So that means the tiles that are closer to the player will be rendered first before calculating the other tiles. But at the moment what happens is, if I go to the top view and simulate, when we simulate, 0 0 0 position is taken as the player position because at the moment we don't have a player when we simulate. But anyway, as you can see here, the tile generation starts from this corner. So it's basically using the order that we that we queue tiles in this queue tiles map. So it doesn't take into account where the player is. So initially this may be fine if we have a like a loading screen or something, but in the runtime we should always prioritize the player. So here, if I switch to the flying and eject, and in the top view let me select the player. So now if I move the player like this, you can see still it starts rendering from the top part. What we should be doing is, we should first render the tiles around the player, so closest tile should be rendered first. So that's what we are going to work on today. So before we get started, I'd like to remind you, like always, you can download the project files of all these projects that I'm doing in my channel in the Patreon page. So once you become a member, you can download anything without a limit and you can use them in your commercial games. Only thing you shouldn't do is like sharing these project files as they are. So to the date, there are over closer to 1700 projects videos that I have done. For each video you can download the project files. So alright, let's get back to the tutorial. So here, the first thing I want to do is, I want to move this queue tiles map into C++ level so that we can download the we can calculate the closest tiles within C++ level. So here is the code. So first thing I want to do is, as I said, I want to move this queued tiles into C++ level. So it has to be a U property and it should not be read only. So U property blueprint read write, and the type is tmap. Key type is fin point, and the value type is int. So I'll use the same name, queue tiles. Okay, now if I save this and recompile, this will be vanished from here because we have this in the upper level. or the parent class of this same class. Okay, so compilation complete. So as I said, that variable is vanished from here. So but it's still here, no compilation errors. Okay, so the next step is we need a function to determine what's the closest tile to be generated to the player. So for that, first we would need a function to get the player's location. So in blueprints we can do it this way. Where is, yeah, we can get player character if it is valid. We can just get the location using get actor location. If not, here I am returning 0 0 because I consider 0 0 0 as the player location for debug purposes. So let's do the same thing in C++ level. The reason I implement this as a separate function is we might need to access player location in multiple places. So that's why. Okay, draw tile, blueprint. I'll make it blueprint callable so we can use this from blueprints as well. Get player. Oh, it will return a vector 3D. Get player location. Right, now let's implement this. So this is the function we need to use to get the player character. It's defined in this Kismet gameplay statics header file. So here, let me add it first. So we need to get a character. So a character pointer player character equals you gameplay statics get player character. So we need to give world context object, get world, and then player index, so 0. Okay, so now if player character by this I check if we have a valid player character. So if yes, we can return player character get actor location. We need to use the header file of the actor, which is this game framework character header file. I don't try to remember these things, I just search and copy. Okay, now the error is gone. So if we have a valid player character, it will return the player character location, otherwise this should return 0 0. If you are not sure, let's sorry, it's actually not there. I just give only 2 numbers. Okay, even if I don't give this, I'm pretty sure it should return 0 0, but better to be sure. Okay, now we have a function to get player location. Then we need another function to get tile location. As the input, we will be giving the tile coordinate. So f vector. So for the tiles, z coordinate does not actually matter because that depends on the height map. So I'll return only a 2D location. So I'll call this get tile location. So we need to give f int point tile coordinate. Right. Let's implement this too. So tiles are like this. If this point is 0, 0, then this point would be 1, 1, 1, 1. This point would be minus 1, minus 1, and minus 2, minus 2. So this is 1, 1 tile, this is 0, 0 tile, this is minus 1, minus 1 tile. So, but as the tile location, I will consider the middle point because that would give us accurate results when we consider or calculate the distance from the player. So rather than taking this point end. So this distance is cell size multiplied by number of vertices. So in this case 50, but we don't get a 50, we get only 50 minus 1 because of the way we have written our functions. So here I'll just implement it. Return f vector 2D tile coordinate multiplied by another f int point. So this would be x vertex count minus 1 and y vertex count minus 1, and then multiplied by cell size, and so that would give the distance to this starting point of each tile, but we need the midpoint. So for that, to get the midpoint, we need to add the half offset, add an offset which gives this half distance. So here plus f vector 2D x vertex count and y vertex count. Well, we should ideally use minus 1 to multiplied by cell size divided by 2. So this gives us the tile location. Okay, so now we need another function to find the closest tile, closest queued tile. So another u function. This will return an element of this queued tile. So that means f int point. Let's return the key. So f int point get closest tile. Right. Let's implement this function also. So we need to iterate through the elements of these Q tiles. For that, we can write a for loop with const auto and entry Q tiles. So now we can access the key. Const key. This should be in the endpoint type. Endpoint and key plus entry dot key and then value equals, so this is a simple integer entry dot value. Okay, now if value is equal to -1, that means according to the way we have defined that here we add -1 when we add a tile index to this Q tiles to represent that this tile is not yet generated. Once we generate, we add the mesh index here. So if this is -1, that means this is not a rendered tile. So perhaps I should have renamed this get closest queued tile. Right. Okay, so if that is the case, now we can get effect to the tile location, get tile location. We defined the function already. Key, because key is f endpoint. Key is an f endpoint, and another effect layer location. So get layer location. No input required. Okay, now plot distance. We can calculate the distance between these two locations. F vector to the distance. So first one is tile location, and the next one is layer location. But this is a 3D vector, so we can convert this to the layer location. Okay, now how do we know if this is the closest? For that, we need another variable, plot closest distance. So here I'll initialize with this the highest value possible for a float. For that, t numeric limits float max. This is how we get in Unreal the higher the limits. Now if distance is less than closest distance, we can set closest distance as the distance, and we need another f in point closest tile. Right, closest tile equals not value, key. Okay, and at the end we should return closest tile. But we have a small issue here. We have no way of knowing did we actually find closest tile, or would we be just returning the default value. But we can solve that in the blueprint level, or in whatever the function that we call this. So what's next? How should we? Oh, we can actually do it here. Yeah, let me compile this. Compilation complete. So now instead of this part, let me just move this down here. Let's call get closest queued tile, and then get queued tiles and find this return value, and we have to check if this value is equal to -1. That means it is not a rendered tile. Okay, if that is the case, we can call generate terrain async, and we can give this tile let me do it like this. Break. Okay, and one more thing, we need to update this queued tiles, and I'll do that inside this generate tile async itself. Not tile, generate terrain. So generate terrain async, this one. So here queued tiles at f int point intersection index x, intersection index y, and the value is mesh index, mesh section index. Okay, save, compile. Okay, time to test. See, now it first renders the tiles around the player, and if I simulate in this view. It should be first rendering tiles here. Let's simulate, see, first around this point, then closest to that point, see. So yeah, that's great. So also if I now start flying, it should generate the closest tile again. See? Perfect. So it gives the priority to the closest tile. And yeah, if we can further test this, if I eject and manually move the player. So if I move the player here, see? Nice. So yeah, it works perfectly. Alright, so that's all I wanted to do for today. So next time what I want to do is, now here, if, let me again fly and eject. So now when the player moves here, now still we have this landscape chunk we have already generated here, but we don't need to keep this. So what I want to do is, I need to unload, or I need to reuse this mesh sections and update it so that we will only have the landscape around the player. That would be better for performance, and also instead of creating a mesh section, updating a mesh section is faster. So that would give us better performance. So we will do that things in the next episode. Alright, so thanks for watching. Updated project files will be available in the Patreon page as always, and link would be in the description below. And see you in the next episode. Goodbye.